do now is go through the anatomy that we reviewed previously and orient you to the structures. We have to do this because language is very complex, and all of the information that we need for language is housed in the central nervous system in the brain. And that's not only the part of the memory that helps us store the words that we want to use and the information that we have to have in order to appropriately interact during a social situation. It's also how we produce information and coordinating the speech structures and comprehending what other people are telling us. It helps in our ability to read and write or text. It can also help with creating narratives or creating new information based on what we've previously learned. I want you to keep in mind as we go through this section that we've really broken down the very basic elements of the brain and the neurophysiology related to language, and understand that there are many more areas involved in language production and language comprehension, but it's really beyond the extent of this course. So what I really want you to know are the main areas of the brain and how they are involved in speech production or language production and comprehension. So this is the picture that we previously looked at in the anatomy section. We can see that this is the front of the brain. We have the two hemispheres here. This is the left hemisphere. This is the right hemisphere. If we look at the side, we can see that this is the left hemisphere. And the left hemisphere houses primarily the information for language. There are things that coordinate back and forth across hemispheres, but what we're going to look at mostly is just the left hemisphere. In 3% of the population, the language area is housed on the right side, but just for the sake of this course, we'll just talk about it on the left side. So here we have the frontal lobe, we have the parietal lobe, the temporal lobe, and the occipital lobe. The frontal lobe is responsible for mostly movement and cognition. It has the motor cortex, which we've talked about before with speech, that controls the movement of the speech muscles, and we also talked about it a little bit in swallowing. And then we have Broca's area. We talked about Broca's area also in speech, but this time I want you to think about Broca's area and how it relates to language in forming our words, our sentences, our phrases, to where they're in a logical order. This is really where Broca's area comes in. And then we have the parietal lobe, and the parietal lobe houses the sensory cortex, so it's mostly related to body sensations and integrating those sensations and what they mean. So it tells us during articulation if we put our tongue in the wrong place that we need to correct it, or it can also tell us if we said the wrong word that we need to correct it. It works with the motor cortex during writing, as we feel the movements of our hand to create the letters or the graphemes on the page. And then we have the temporal cortex. This is where it's mostly for speech recognition or recognitions of any sounds, and it works with Wernicke's area to understand and interpret speech. So Wernicke's area also helps with naming and producing meaningful speech, and it works with the parietal and occipital lobe for reading and writing. We have the occipital lobe, which is primarily for visual processing, so it's going to help us with our nonverbal language like gestures. It's also very important for sign language. It helps with eye contact during conversations, and it helps with reading and writing in collaboration with the Wernicke's area and the sensory cortex. What you'll see by now is that language is very complex again, and we have to have coordination among the structures. So here is, again, another summary of the areas involved for the production of language. We have Broca's area that helps with the motor programming for articulation, as well as the production of words in a logical order, sentences in a logical order, and the construction of phrases. We have the motor strip that activates the muscles for articulation. You'll see in the picture that the motor strip is very close to Broca's area, and we have Broca's area here in the frontal lobe. And that's how those two communicate very easily. So we have that information being sent from Broca's area and that integration of that information. And then the signals for the coordination of that from the motor cortex that's going to go to the cranial nerves and send them down to the speech organs. Then we have the Arcuate Fasciculus. It's the branch between Broca's area and Wernicke's area, so it transmits information from front to back. and it also integrates that information between the two areas. So in order to produce speech and store the information for the comprehension and creation of meaningful speech, we have to have that branch between the two areas. And then we have 3 additional areas for integration for reading and writing and sensory information. So the angular gyrus, which helps integrate that visual, auditory, and tactile information for reading and writing. We have the supramarginal gyrus that's going to help with the symbolic integration for writing, so the ability to see and understand those graphemes or those letters on paper. And then we have subcortical areas like the thalamus for naming and memory. That also works with Wernicke's area. And then we have the insula, the internal capsule, and the basal ganglia, which are the language and speech mechanisms. I'm not going to test you so much on these different areas. It's just to illustrate how complex the language system is.